Hi, welcome to lesson 10.7, circles in the coordinate plane. So for today's lesson, you are going to need a couple of pieces of paper and also a couple of pieces of graph paper. So go ahead and pause the video whenever you're ready. This is on page 308. You are going to need a blank piece of paper like this. Okay, divide it into two pieces. This is going to be for problem number 1. And please attach a little piece of graph paper on the side. Okay, so this is for problem number 1. And we're going to be doing a little something right here in just a bit. For problem number 2 and problem number 3, you're going to do exactly the same thing. You're going to put a blank piece of paper right in the middle. And then you are going to put two pieces of graph paper, one for number 2, one for number 3. Because we are going to be doing a little bit of graphing today. We're going to be graphing circles. On page 310, you are going to be placing two pieces of graph paper, one here at the top and one here at the bottom. And that's going to be for problem number 4 and problem number 5. Okay, this is on page 310. Okay, so whenever you're ready, pause the video and go back to page 308. Okay, so let me zoom in a little bit so we can see what we're doing. Okay, so basically what we're going to be doing is we're going to be deriving the equation for a circle in a graph. All right, so I'm going to go ahead and just sketch a graph. Okay, nothing fancy. Okay, just like that. And I'm going to be selecting the center of the circle, and the coordinate for the center of the circle is going to be HK. Okay, so this distance right here is going to be H. This distance right here is going to be K. Now I'm going to draw a circle with a given radius. Okay, as best as we can. All right. All right, so the radius, we are going to call that R. Now, we're going to let this point be a point on the circle, and the coordinate of that point is going to be XY. Okay, so this right here, this is the center of the circle. We have a radius R, and the point on the circle is going to be represented by the coordinate XY. So what we're going to do is we're going to create a right triangle from this. Okay, now the coordinate for this point right there is going to be X right there. Okay, so the coordinate of this one is actually going to be XK. All right, and the coordinate of this one, we already know it's HK. Okay, so this one is HK. All right, so I want to focus on two things. I want to focus on this distance right here being equal to this distance right there. All right, and this point right here is going to be my Y value. All right, so I want to focus on this vertical distance right there, which happens to be the same as this distance right there. But what exactly are those two distances? Well, this distance right here, the one in green, is going to be the value of X minus H. So X minus H is the distance from here to here. The distance from here to here is going to be Y minus K. All right, so we know this distance right here is X minus H. This distance right here is Y minus K. So if I apply Pythagorean theorem, I'm going to get the following. Okay, I'm going to get R squared equals, okay, this distance here and that distance right there. Hence, now we have the actual equation of a circle of radius R. Okay, so this is the equation of a circle with radius R and center HK. All right, so our goal is to be able to not only create these equations, but also graph them. All right, so that's pretty much the exploration. Let's go ahead and start some of the examples. All right, so let's take a look at example number 1. All right, so pause the video so you can graph the circle that is provided to you right there. And it says write the standard equation of each circle. All right, so we need to remember the equation is the following: x minus h quantity square plus y minus k quantity square equal to the radius square. So let's look at A first. The circle shown at the left. So I need two pieces of information from this in order to create the equation. I need the center of the circle and I need the radius of the circle. So for the center of the circle, obviously it is centered at the origin. Okay, and the radius of the circle is the distance from the center to the circle, which in this case, that's going to be 1, 2, 3. So the radius is equal to 3. So all we need to do is substitute those values into the equation. X minus 0, y minus 0, because that's our x, not our x, this is our hk. All right, quantity square equal to 3 square. So once we simplify it, we have x squared plus y squared equals 9. And that is the equation of the circle. So if we can simplify it, simplify it. If not, then leave it as is. All right, so that's A, 1A. All right, for the next one, here's what we have. We do have the center of the circle, and we do have the radius of the circle. All right, so we're going to do exactly the same thing. Okay, so our center is at 0, negative 9. That's going to be my h and my k, and my radius is 4.2. All right, so what we're going to do is we are simply going to substitute those values into the equation. Okay, that's going to give me x minus 0 quantity square plus y minus negative 9. We got to be careful because that's going to turn into a plus, equal to 4.2 quantity square. Okay, so when you're simplifying this, we need to take a look at what that decimal is going to be. So that's going to be x square plus, we're going to leave this as is. Okay, and 4.2 quantity square, that's going to give me about 17.64. Okay, and that is example number 1. Let's take a look at the next example. All right, in the next example, okay, go ahead and pause the video and copy the graph. Okay, the center is at negative 1, 3. The point is at negative 5, 6. All right, so the point is negative 5, 6 is on the circle with a center of negative 1, 3. So here's the thing. If I was to write the equation of the circle, I would have x minus negative 1 quantity square plus y minus 3 quantity square equal to the radius square. So here the radius is my unknown. Okay, this will simplify to x plus 1 quantity square, and then y minus 3 quantity square. So our goal is to figure out what is r going to be. Now the book does it like a distance formula, but I'm thinking to myself, distance formula is pretty much what this is. So I'm going to use the point negative 5, 6. So the point negative 5, 6 is a point on the circle. So I'm going to substitute those values into x and y and determine what r square is going to be. All right, so it's going to look like this. Negative 5 plus 1 quantity square, 6 minus 3 quantity square equal to the radius square. So that's going to give me negative 4 quantity square, 3 square, okay, that's 16 plus, now 3 squared, that's going to be 9, which gives me the radius square, and that gives me 25 equal to the radius square. Now, do I really need to know the radius? No, but if you wanted to, you know that the radius is going to be 5. Okay, The radius, if I do the square root, is going to be 5. But I need my equation in terms of r squared. So my final solution is going to be x plus 1 quantity square plus y minus 3 quantity square equal to 25, because that is what r squared equals. Hence, now this is the equation of the circle. All right, let's go ahead and take a look at the next one. Example number 3. Okay, so this one is a little bit more involved because we are looking for the actual center of the circle. All right, so here's what we have. We have x squared plus y squared minus 8x plus 4y minus 16 equal to 0. Okay, so what we need to do is we need to group all the x's together and all the y's together, and we're going to be doing something called completing the square. All right, so x squared minus 8x. Okay, now I'm going to leave a little space in between there, and you'll see why. Okay, plus y squared plus 4y, and then I'm going to leave a little space right there, and I'm going to set this equal to 16. Why 16? Because I'm going to move this right here over on this side, okay, by adding 16. And you're going to see why we're going to do that. Okay, so that's going to give me 16. So going back to algebra, I need to find a number right here that is going to give me a perfect square trinomial. Okay, so that number is going to happen by looking at this number and looking at what half of that is. Half of negative 8 is negative 4. So negative 4 quantity square, that's going to give me 16. Okay, so I'm going to add 16 here, and because I added 16 here on this side, I'm going to add 16 here on this side to compensate it and keep it equal. Half of 4 is 2. 2 squared is 4. So I'm going to add 4 here, and I'm going to add another 4 right there. Now, why did I do that? The reason why I did that is because if you remember back from Algebra 1, if you have the following, okay, if you have x plus a quantity square, that's going to be x squared plus 2ax, the product of these two, plus this right here, square. So that's why I divided by 2 on this one, because I'm trying to find what half of that's going to be so that I can square it and add it in here. Because now this part right here is going to be x minus 4 quantity square, which is the same thing as x squared minus 8x plus 16, plus, and that's called completing the square. Hopefully you remember that from Algebra 1. All right, and that's going to be y plus 2 quantity square. If you were to do this rule up here, that would be y squared plus 2 times y times 2, that's 4y, plus 4 squared. And that is going to give me whatever this is going to be. So that's 32, 33, 34, 35, 36. Okay, so because that is 36 and this is equal to r squared equals 36, that gives me the radius to be 6. So with that, I can actually graph my circle. All right, so how do I graph it? Well, first off, let's look at where the center is. The center is at negative 4, 2. Okay, so negative 4, 2. That's the center of the circle. So now since my radius is 6, I'm going to count 6 units this way, 6 this way, 6 upwards, and 6 down. 1, 2, 3, 4, 5, 6. And then from here, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So after this, there's no way to count 6 this way. So you're just going to sketch your circle as best as you can. If it doesn't look like a circle, don't worry about it. I've been doing circles for 15 years, and they don't always come out very circly. That's even a word. Right, and that is the graph for the equation of the circle. Okay, now if you need a little bit of a refresher on how I did this right here, go ahead and go on YouTube and look for completing the square. Okay, that's an Algebra 1 skill that you need in order to do this. All right, so that is example number 3. All right, let's take a look at the next one. It says, prove or disprove that the point square root of 2 lies on the circle with center at the origin and containing this point. So first thing we need is the equation of the circle. All right, so the equation of the circle is the following. Okay, x minus 0, let me zoom in a little bit. X minus 0 quantity square plus y minus 0 quantity square equal to the radius square. Okay, I don't know the radius yet. I'm going to figure it out. So this is going to be x squared plus y squared equal to the radius square. Now, it says that lies on the origin with center at the origin containing point 2, 0. Now, if you really think about it, okay, if it's at the origin and another point is at 2, 0, you know the radius is going to be 2. Okay, but let's say we don't know that. Okay, what I'm going to do is I'm actually going to plug these values into the equation because they might give you a point that is not on the axis. If it's on the axis, it's really simple. So if you don't have it on the axis, all you got to do is just plug it in. That's going to give you 2 squared plus 0 squared equal to the radius square. And when you simplify that, you're going to get the radius square equal to 4. Okay, which means the radius is 2. All right, so the actual equation of the circle now is this. So now we can figure out if this point is actually on the circle. How do we know? We plug those numbers into the equation. If it equals 4, it's on the circle. If it doesn't, then it's not. So square root of 2, that's the value of x and y. So when I plug those in, I'm going to get the square root of 2 square root of 2 square, and I'm going to see if that actually equals 4. So I know that these are opposite operations, so they undo each other. That gives me 2 plus 2, which is indeed 4. So that means that the square root of 2, that point is on the circle. If it did not equal, then it would not be on the circle. All right, so that is example number 4. All right, let's take a look at example number 5. All right, so it says here, the epicenter of the earthquake is the point on the Earth's surface directly above the earthquake's origin. A seismologist can be used to determine the distance to the epicenter of the earthquake. Seismologists are needed in 3 different places to locate an earthquake's epicenter. Okay, so basically I'm going to be graphing 3 circles. Now it's going to get a little ugly, okay? So the epicenter is 7 miles away from this point. It's 4 miles away from this point and 5 miles away from this point. So what we're going to do is we're going to graph all 3 of those circles and determine where basically the 3 circles are going to meet. Okay, so it's going to be a rough sketch. Okay, all right, so let's start with A. Okay, -2 and 2.25 is going to be the center of the circle, and it's 7 miles away. So I have to count 7 miles left and right. Okay, so that is 1, 2, 3, 4, 5, 6, 7. Okay, so from here, okay. Okay, so here's where it's going to get a little interesting. So it's going to be 1, 2, 3, 4, 5, 6, 7. Okay, so from here, 1, 2, 3, 4, 5, 6, 7. Okay, and from here, it's going to be, let me see, 1, 2, 3, 4, can't see that, 5, 6, 7. So it's going to be about right there. So we're going to sketch that circle. Now, maybe I should be using a compass for this. Probably keep it a little bit cleaner. Okay, so from here to here, it should be about the same. Should be about the same. So yeah, I recommend you use, probably should have done a little bit smaller. It's not going to be that accurate, guys, but we're going to do the best we can. Here I am twisting my arm, guys. All right, so that's the first one. Okay, the second one is at 4, 6. Okay, that's the center, and it's 4 miles this way, 4 miles that way, 4 miles this way, and 4 miles this way. So I'm going to go ahead and use my compass. Okay, measure it at 4 as best I can. Okay, and then the last one is at 3 and negative 2.5. So it's going to be right there. And the radius is 5 units away. Okay, so 5 units away. Hold on, my pencil's acting out. Do I have another pencil? I have one here. Okay, where am I? Okay, so 5 units away. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Can't see that. All right. So I'm going to grab this, measure it 5 units away as best I can. All right, so the epicenter is going to be where all 3 circles meet, and it just so happens that they all meet at this point. And that point right there is going to be 5, 2. Okay, so the epicenter is at 5, 2. So to keep this clean, I honestly suggest that you use a compass. All right. Oh, there's the bell. Trying to finish before the bell. All right. Okay. Yes, I'm in my classroom. All right, so guys, that is the last question in example 5. Okay, and thank you for watching our videos. Bye-bye.